Then, yeah, welcome and good morning from Austria. I'm very glad that so many are here and joined this meeting. I will start with the presentation. Give me 1 minute. You can see the presentation?
Yes, Christopher, go ahead, go ahead.
Okay, perfect. Yeah, I would like to thank you in advance for this opportunity, and I am pleased to introduce today the iFiber to you. Topic today, as already mentioned by Mr. Goyal, will be don't let rejects take away your precious fibers. Let's start once more again with short words about myself. My name is Christopher. I'm 33 years old, live in Austria in Carinthia. Already spent more than 80 years for IBS and PGA, and I'm responsible for the product iFiber as a product manager. For sure, questions arise during this presentation. Some will be answered during the presentation itself, and the rest you can ask me or my colleague Alfred or Mr. Manoj in the end of the presentation. Now, I wish you an interested presentation. Don't let rejects take away your precious fibers. Content of this presentation will be as follows. Basic process of waste paper in a paper mill. What is the iFiber and where is it used? A possible installation position, for example. Components of the iFiber. Applications and case studies from successful installations. References. We have also prepared a return on investment calculation with Indian numbers. Question answer season in the end of this presentation. Okay, let us start with the basic process of waste paper preparation. Waste paper is collected in numerous quality grades and used for many types of paper. For example, packaging paper and tissue. Waste paper is dissolved and suspended together with water in a pulper, whose mode of operation is similar to a kitchen mixer. The dissolved stock suspension is then cleaned by means of a cleaner, here the orange part. Particles such glass, stones, screws are separated in this step. In the next step, the stock suspension is sorted into accept and reject, the yellow part. This process is carried out by a screen, for example. If necessary, the cleaned and sorted stock suspension will be further improved. This will be done by a commercial refiner. The finished material goes ahead to the paper machine. Okay, in the next slides, we will go into a little bit more into detail about each step. On this slide, you can see on the left a conversion pulper and on the right a cleaner. As mentioned before, the paper is mixed in the pulper with water, dissolved and roughly sorted. Large plastic parts, wires removed via a pigtail winch here, and the accept good stock go ahead in this direction. The next step is cleaning by means of a cleaner. The stock suspension enter the cleaner here on this part and is set into a rotation action. The heavy particles, such glass, screw, stones, are thrown outwards and separated here in the bottom. The good stock fibers are separated upwards in this direction. Here is a video where you can see this process in a cleaner. I hope you have seen this video. Yes, perfect. You can see the heavy parts go outside, and here you can also see this heavy reject are separated. Here some screws, glass, stones, and so on. Next one, or the next steps, sorting and improving. Here on the left side, a screen, and on the right side, a double disc refiner. At the sorting, the stock suspension enter the screen here at the top. The individual and accepted fibers slip through the slots or holes. Those that do not slip through are sent to the next screening stage or to the rejects here in this part. A refiner, like here, this part, improves the fiber and makes it fibrillated. Higher strengths are generated. The double disc refiner consists of two grinding discs that rotated in opposite direction. Here, the fibrillation takes place between the two grinding discs in the grinding gap. Okay, that was the basic process, more or less, of waste paper preparation. Now to the topic, how we can save your precious fiber. IBS BGA has developed a machine named iFiber. This machine is divided into 3 product groups. The T-tuner, a T-tuner is explicitly designed for the optimization of refiner lines connected in series for saving energy. A deflaker homogenizes the stock suspension energy efficiently without shortening or destroying the fiber. But today, we will take a closer look at desaver. The desaver improves the efficiency of existing screening plants in waste paper OCC stock preparation. The goal of an installation is keep more fibers in the process and reduce landfill quantities, saving of raw material. When is a desaver recommended? If you have high fiber losses, if you have high reject quantities, if you have high reject disposal costs, if you have process instabilities, plugging of screens, for example. And what are your benefits? We are able to reduce the reject quantities up to 30%. Increase your fiber yield, in particular long, high quality fibers. Less raw material needs to be purchased, and as we see, the prices are going up and up at this moment. The recommended application for an iFiber desaver is in the reject line after the stage 1 or 2 in the fine screening. After first stage here in the reject, or after the second screen in this area. If we have more fibers available to slip through the screen or the basket, we reduce rejects here. This will be done by the working principle of the iFiber desaver. Open existing fiber bundles without destroying your fiber. fibers. IBS BGA recommends, if possible, the installation after the second screen stage. Why? The flow is lower, means the machine becomes smaller and cheaper. We would see the picture below, bigger, this one, and I will explain this in detail, what we see here. What is the I-fiber desaver? In the next slides, some details. The I-fiber is a high shear mixer and operates continuously with consistency between 2 and 6% and is specifically developed to reduce fiber losses in the fine screening of OCC and to save landfill costs. The I-fiber creates a high frequency of intense fiber to fiber friction. That means fiber to fiber is you have a high friction. Without shortening, we don't cut the fiber. The fibers doesn't generate any fine materials. That's not a commercial refiner. Cut your fiber, and we don't cut the fiber with this machine. And we don't generate any fine material. Units from 10 cube meter per hour up to 350 cube meter per hour are available. It's a very big range. Here you can see an installed I-fiber, how it looks. How the I-fiber desaver works. On this slide, on the right corner here, you can see a cross section of the I-fiber desaver. The bulb suspension enters the fiber at the top here, in this area, is lead to the rotor. This is the red part. This rotor turns with a very high speed. Here also the rotor, and is thrown against, the suspension is thrown against this starter, and this circulate internally, for example, 7 times, working continuously. Due to fiber bundles, sheaves and flakes are opened and valuable fibers are returned. We have more fibers available to can slip through the screen. And without shortening, as already mentioned. In order to achieve the best possible results with the I-fiber, we can work with some figures. Rotation speed of rotor design, we can play with the height of the teeth. You can see here, these teeth. And dwell time internally, flow rates, and stock consistency. And when you have a higher consistency, for example, 6%, you have more friction between fiber. That's better for the I-fiber. Here, nice to see how it works, but now with water. This turn with a very high speed, the rotor. The stock suspension enters here, and now you will see we get water come in. And then the stock suspension returns here in this cycle and thrown against here to the stator. Components of the I-fiber. The heart is located here. As already said, rotor and starter. For your expansion, lifetime of rotor is depending on raw material, but normally 6 months, more or less, and the stator 12 months, depending on raw material. The mechanical sealing of the machine so that no medium can flow out. This will be controlled by a safe unit. Sealing medium is water. You can see here. The rotor is mounted on the ball bearings. One here, one here. Bearings are grease lubricated and installed in the standard bearing housing with integrated sealings. For power transmission serves the engine and the elastic coupling. Engine and the elastic coupling. And all parts are mounted on a stainless steel frame, and the machine is placed on vibration dampers. That means no special foundation is necessary. In the next chapter, I will present you some field installation of the I-fiber. Let us start with a field installation of a German customer. The I-fiber saver was placed in the reject line of the fine screening before the final stage. A detailed flow sheet will follow in the next slide. Some paper machine and product details. Machine type was a gap former. Raw material used 100% OCC, B12 and B19. Product test liner, grammage range 80 up to 130 grams per square meter. Production 420 tons per year. Maximum speed of the machine 1,400 meter per minute, and the working width 7.5 meter. I-fiber details, position, fine screening before final stage. We will see in the next slide the flow sheet. Size of the machine 70 cube meter per hour. Consistency 2 is up to 3%, and the installed engine was 55 kilowatt. Here is the promised flow sheet. In this installation, we have a 3-stage fine screening slotted. The I-fiber is placed in a reject line as recommended by BGA after the second screen, with the goal to increase the accept, the green line, and reduce the rejects. Which in turn means save raw material and reduce in the end of the day, the landfill. How could we achieve this goal? We have increased the accept in this case in the third stage by 12.8% and have decreased the reject amount by around 25%. In addition, we have prepared a small calculation with numbers. 12.8% means 147 cube meter per day. In the next step, we calculated the dry quantity. With the result, we keep 3.68 tons accept per day back in the process. This returned fibers multiplied by the production days, 350, and the material costs with, in this case, or during this time, 150 euro. Now we are 100 more. Results in a saving of 193,200 euro. On the other hand, as already mentioned before, we have decreased the reject by around 25%. Unfortunately, we have no received any figures from the customer in this case, but as promised, we have prepared a return on investment calculation with Indian figures in the next chapter. Highlighted this project once more again. We have increased the accept up to 13%, reject quantities reduced by 25%, no significant size reduction of stickies, and no plugging of the downstream shortening stage. References: we have installed a total of 11 machines. First one was Salza. We have also a machine installed at Italy, Polesine. This is confidential. France 1 and 2. In total, you can see 11 machines from a range 30 cube meter per hour up to 350 cube meter per hour. And we are placed in graphic paper, packaging paper, liner board, also in tissue, special paper, and many projects are in discussion. Palm Group, Mondi Group, Smurfit Kappa, and now we are also in the tissue sector. Next installation by a customer in Italy. This is the promised picture. Here we can see again this picture from before. Aim of the installation: reduction of landfill and save raw material. What has been achieved? Rejects could be reduced by up to 30%. This picture here, This picture here shows a time comparison with and without I-fiber. Left side without I-fiber and the right side with I-fiber. Same time. As you can see, significant reduction of reject quantities due to use of an I-fiber desaver. Significantly without I-fiber left side and with I-fiber here on the right side. Same time, 1 hour here, 1 hour here. Here are a picture from an installation in the early May this year. Samples were taken after the screw press in the end of the process. I'm reduction of landfill and safe raw material. This customer use 100% OCC and produce packaging paper. We use the unit before the last screening stage. During this test, we were only able to treat approx 30% of the total flow. Nevertheless, as you can see, the significant reduction in the amount of fiber. Without I-fiber, you can see the closed surface. After treatment, the waste has no binding and is more open. Here. Means less fibers are in the waste and more in the process. This was a big success, and now we will install by this customer also a production machine. We have already seen part of this 2 cleaner counts. This comparison comes also from an installation. Let's start with the left and the right video together, then you can see the difference between, you have here on the left side without I-fiber, a high content of fibers. That means that the brown part, and on the left side with I-fiber, you can see in the rejects, there are no fibers. I will play this together, these videos, then you can see this difference. So you can see here with the I-fiber, this is very clean, no fibers are inside, and only the heavy parts such glass, sand and stones here are in. Now let's calculate a return on investment example with Indian prices. Payback saving calculation is based on a desaver with 30 cubic meter per hour. Mill production is 425 tons. Product test liner furnish 100% OCC and costs applicable in India OCC $260. That means 218 euro per ton in Europe. Energy costs around 8 rupee per kilowatt hour. The landfill costs, transporting and dumping are between 1,000 and 1,500 rupee. For your explanation, 1 euro is 88 rupee and $1 is 73 rupees. Amount of fiber rejects from the screening in this case are 30 tons per day wet. We have 350 days of production. The water content in the reject is 55%, and the reduction in the reject fiber saving is around 25%. In this case, we can return 3,375 tons per day dry back to the process. This means 1,181.25 tons per year dry back. When we have cost of the fiber, what we have saved, we have 736 per day, or in rupee 6.5 per day rupee. That means 205,007 per year, or 2.26 crore. We have saving of fibers. Of course, we still have to deduct energy costs and maintenance wear parts. Results in a net saving of 1.77 crore. Furthermore, if we return more fibers to the process, the reject quantities are of course also reduced. With the calculated 25%, we get the following results. Saving in the reject handle, we have per day 7.5 tons per day wet. That means we have a saving of 26.25 lakhs per year, calculated on 1,000 rupee per ton. And total saving with D and E, we have 2.03 crore per year of savings in this case. Now we are in the end, and I can only say saving precious fibers with the BGA iFiber T-Saver. Make your paper machine eco-friendly, use resources in a valuable way, increase efficiency, and increasing your profit. Thank you for your attention, and I'm looking forward to meet one or the other in India personally. And until then, stay healthy. BGA, your partner for advanced technologies. Thank you very much.